We know the derivative of cos is minus sine, but since we have x cube here, you have to use the chain rule. That is, derive the first function, then derive the function which is inside one more function. So you have a function in the form of x power n, where n is a constant. But here we have a function in the form of x power x, where both are function. The numerator is in the form of sin a cos b minus cos a sin b, which is nothing but sin a minus b. Hello everyone, a warm welcome to one and all. This is Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. We are at the revision of chapter-wise question and answer. In this session, I'll be taking the chapter that is Differential Calculus. So, we will be solving questions on the chapter Differential Calculus, which you may expect for your examination. From the chapter Differential Calculus, in this session, we will be discussing about 1 and 2 mark question. Let's see the distribution of marks from this chapter. So, in Differential Calculus, you will be having 1 mark, 1 2 mark, 1 3 mark and 1 5 mark question. Total, you have 11 marks from this chapter. But in this session, I'll be taking only 1 mark and 2 mark question. Let's see what are the type of question they may ask you from the chapter Differential Calculus. First question, find dy by dx if root x plus root y is equal to 3. So, 1 marks contains very simple differentiation of the functions. So, here we have a function root x plus root y is equal to 3. You have to learn all the standard results of differential calculus, that is the derivative of each and every algebraic trigonometric functions. Here we have root x. So, we have root x plus root y is equal to 3. So, when you derive this, root x is nothing but differentiation of 1 by root x is 1 by 2 root x and differentiation of root y is 1 by 2 root y. Since you are differentiating y with respect to x, you have to write dy by dx. Derivation of a constant is 0. Here we have 1 by 2 root y. Dy by dx is equal to, I will shift minus 1 by root x to that side, it becomes minus 1 by 2 root x. I can cancel 2 and 2, then I'll get dy by dx is equal to minus root y shift here, then it becomes root y divided by x. So, this is the derivative of the given function. Next one, if y is equal to cos x cube, find dy by dx. We know the derivative of cos is minus sine, but since we have x cube here, you have to use the chain rule. That is, derive the first function, then derive the function which is inside one more function. So, y is equal to cos x cube means dy by dx is minus sine x cube, and again you have to derive x cube. So, therefore, it is minus sine x cube into derivative of x cube is 3x square. Hence, the answer is minus 3x square into sine x cube. So, this is the derivative of the given function. Next one, y square is equal to 4ax. Find dy by dx. This is an implicit function. You have to derive y and x at a time. So, if you have y square, the derivative of y square is 2y. Since you are deriving y, we have to write dy by dx. 4a is a constant and derivative of x is 1. Now, here I can cancel 2 1s are 2 2s are. So, I will get dy by dx is equal to 2a divided by y. So, this is the answer. Next one, if y is equal to e power x, x power e power a, find dy by dx. So, we know that the derivative of an exponential function is itself, that is e power x is e power x. When you have any function in the form of x power n, the derivative of x power n is n into x to the power n minus 1. So, we have to write this as e into x power e minus 1. Now, here e is a constant and power in terms of e is also constant. So, therefore, e power e is a constant function. Hence, this is 0. So, therefore, dy by dx here is e power x plus e into x power e minus 1. Next question. Differentiate 5 e power x minus log x minus 3 root x. So let us take y is equal to 5 e power x minus log x minus 3 root x. Now let us derive it. We have dy by dx is equal to 5 into derivative of e power x is e power x, derivative of log x is 1 by x, minus 3 is a constant, derivative of root x is 1 by 2 root x. Hence, the value is 5 e power x minus 1 by x minus 3 divided by 2 root x. Next question. If y is equal to e to the power log of cot x, find dy by dx. So, any function in the form of e log of f of x can be written as f of x. Because e and log are inverse to each other. A function with its inverse gives the function itself. So, therefore, if you have e power log into any function, then you have to take y is equal to f of x. So, here I can take y is equal to cot x. What is derivative of cot x? Derivative of cot x is minus cosecant square x. So, like this, they will ask you very simple question to derive a given function either using a chain rule or any simple implicit functions. Next, we will look on 2-mark question. If y is equal to root of x plus root of x plus root of x until infinity, then prove that dy by dx is equal to 1 over 2y minus 1. So, let me take root of x plus until infinity as y itself. So, in the place of this, I will take y is equal to root of x plus y, where y is nothing but root x until infinity. Now, squaring on both sides, I will get y square is equal to x plus y. Now, let us derive the given function with respect to y. On the left hand side, we have y square. So, this becomes 2y into dy by dx. And here on the right hand side, it is 1 plus dy by dx. So, let me shift dy by dx here. If you take it as constant dy by dx, then here we get it as 2y minus 1 is equal to 1. Therefore, dy by dx can be taken as 1 divided by 2y minus 1. So, take the remaining value of root x in terms of y, square on both sides, then derive it. You can get dy by dx is equal to 1 over 2y minus 1. Next one. If y is equal to x power x, find dy by dx. So, you have a function in the form of x power n, where n is a constant. But here we have a function in the form of x power x, where both are function. So, whenever you have a power function, then apply log on both sides. If you apply log here, log y is equal to log x power x. We know that log x power y can be written as y log x. So, similar way, I can write this as log y is equal to x log x. Now, derive the function. Derivative of log y is 1 by y into dy by dx. So, when you are differentiating y, you have to write dy by dx. Now, here let us apply the product rule. First function into derivative of second, that is log x 1 by x, plus second function into derivative of first, that is derivative of x is 1. So, here xx get cancels. I can write here dy by dx is equal to, there you will get 1 plus log x into y. If you shift y here, you can write. So, or you can write dy by dx is equal to, you can replace the value of y as x power x. So, it becomes x power x into 1 plus log x. So, either you can stop here or you can replace the value for y. Next one, if y is equal to log of 1 minus cos x divided by 1 plus cos x, prove that dy by dx is equal to 2 cosecant x. So, here y is equal to log of, I can write 1 minus cos x as 2 sine square x by 2 divided by 2, 1 plus cos x as 2 cos square x by 2. So 2 get cancelled. I will get log sine square by cos square can be written as tan square x by 2. Now let us derive this function. Dy by dx is equal to, first we have a log function. Log of tan square x by 2 is 1 by tan square x by 2. Next, let us derive tan square x by 2. It is 2 into tan x by 2. Now, let us derive tan x by 2. Tan x by 2 is secant square x by 2. Now, finally, let us derive the function x by 2, that is equal to 1 by 2. So, when you derive log, it will be in the form of 1 by x. Now, since we have here it is in the form of x square, first derive it in the form of a 2x. So, it becomes 2 into tan x by 2. Then again differentiate tan x by 2. You will get secant square x by 2. Secant square x by 2, since you have it in the form of x by 2, derive again x by 2. So, you will get half. So, we can cancel 2 and 2 here. 1 tan x by 2, 1 tan x by 2 we can cancel. Next we are left with dy by dx is equal to secant square can be written as 1 by cos square x by 2. And here we have tan x by 2. We can write this as sin x by 2 divided by cos x by 2. So I can cancel here cos x by 2, cos x by 2. I can write dy by dx is equal to 1 divided by cos x by 2 divided by sin x by 2. So I will multiply 2 and divide by 2 here. Then it becomes dy by dx is equal to 2 divided by 2 sin x by 2 cos x by 2. Again, this is a half angle formula. It is in the form of 2 sin x cos x, which is nothing but sin 2x. But here we have x in the form of x by 2. So 2x will become sin x. So instead of sin 2x, I'll just write sin x. So this can be written as 2 divided by sin x. But what is 1 by sin x? 1 by sin x is cosecant x. So therefore the answer is 2 cosecant x. So here again using all the half angle formula, 1 minus cos x can be written as 2 sin square x by 2. 1 plus cos x can be written as 2 cos square x by 2. Cancelling 2 we get tan x square by 2. Now deriving it, log of x is 1 by x square in the form of 2x. Again differentiating x, that is tan x by 2, we get secant x square by 2. X by 2 differentiation is 1 by 2. So cancelling the common terms, we are left with secant square by tan. Secant square can be written as 1 by cos square. Tan can be written as sin by cos. Cos get cancelled. We got cos x by 2, sin x by 2. Multiply 2, divide by 2. We'll get the denominator in the form of 2 sin x by 2 cos x by 2, which is nothing but sin x. Half angle formula. So here replacing this in the place of this, write sin x. Now 1 by sin x is cosecant x. So replace it back. Therefore the derivative is 2 into cosecant x. Next one, find dy by dx if x power y is equal to y power x. So I already said you, when you have any function in the form of a power, that is x and y, or in the power form or exponential form, apply log on both sides. So applying log on both sides, here we get log x power y log y power x. So here I get y log x and here I get x log y. Now differentiate both sides. So both left hand side and right hand side I have to apply the product rule. So first function into derivative of second plus second function into derivative of first. Y into derivative of log x is 1 by x plus log x into derivative of y is dy by dx. Now here x into log y is 1 by y into dy by dx plus again log y into 1. Now let us take dy by dx on your left hand side. So if you take dy by dx here, then it becomes log x minus x by y. and on your right hand side you have here log y, and shift y by x that side, it becomes minus y by x. So here we get dy by dx is equal to y log x minus x divided by y, and here we get x log y minus y whole divided by x. So therefore dy by dx can be written as y into x log y minus y divided by x into y log x minus x. Next one, if sin y is equal to x sin a plus y, prove that dy by dx is equal to sin square a plus y. So first let us take here x is equal to sin y divided by sin a plus y. So here instead of differentiating with respect to x, we are differentiating here with respect to y. Differentiate with respect to y. So when you are differentiating with respect to y, no need to write dy by dx, but when you have x, you have to write it as dx by df. But in the place of x, you have to differentiate with respect to y. So x becomes dx by dy. So if you are differentiating y, then it becomes dy by dx. If you are differentiating x with respect to y, then it becomes dx by dy. So here we have to apply the quotient rule. So that is u by v form. Okay. So here sin a plus y into differentiation of sin y is cos y minus sin y into differentiation of sin again is cos a plus y, and differentiation of y is again 1, because here we are differentiating y with respect to y, no need to write dy by dx, whole divided by sin square a plus y. The numerator is in the form of sin a cos b minus cos a sin b, which is nothing but sin a minus b. So I can write this as dx by dy is equal to sin a minus b form, which is sin square a plus 1. Now cancel plus y minus y here. So we get here dx by dy is equal to sin a divided by sin square a plus y. Now take the reciprocal, because we need dy by dx. Here we have dx by dy. So therefore dy by dx is equal to sin square a plus y divided by sin a. Hence we have proved it. So when you are differentiating with respect to y, write dx by dy, and here no need to write dy by dx for any function, because we are differentiating y with respect to y. So therefore just go on differentiating. Here this is in the form of sin a cos b minus cos a sin b. Apply the sum formula of sin a minus b. So therefore it becomes sin a, because plus y minus y cancel. Then take the reciprocal, we get dy by dx is equal to sin square a plus y divided by sin a. Next one, if y is equal to x to the power sin x, find dy by dx. Again apply the log function here. We get log y is equal to sin x into log x. So we get log x to the power sin x. Power can be written as sin x into log x. Log y is 1 by y dy by dx. Here we have to apply the product rule to differentiate. First function differentiating second plus second function differentiating the first. Now here we have dy by dx is equal to y into sin x divided by x plus log x into cos x. So or you can replace back the value of y as x to the power sin x. Next question, If y is equal to a square minus x square to the power 10, find dy by dx. Any function in the form of x to the power n is nothing but n into x power n minus 1. So here dy by dx can be written as 10 into a square minus x square whole to the power 9. Again derive the function inside the bracket. So we will get 10 a square minus x square whole to the power 9. Derivative of a square is 0 minus derivative of x square is 2x. Now multiply it. 2 minus 2 tens are 20 x into a square minus x square whole to the power 9. This is the derivative of the given function. We will continue with few more problems in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.